the first thing then. The first thing is all this idea about mapping, okay? You guys remember what we were working on last week, okay? We were working on this idea of being able to map from one set of numbers onto another set of numbers. One set of numbers in a range onto another set of numbers in a range. And in order to do this, we just use like our kind of primary level sort of maths, percentages and fractions and stuff in order to do that, okay? But what we might try and do now is like processing actually as a built-in method for doing a lot of the stuff that we did manually last week. But just to understand that area in a little bit more detail, we'll try and write our own one first of all. So let's think about a very simple problem. The problem we were kind of thinking about last week was this idea of, this little problem of like calculating how much certain number of oranges are going to cost. Okay, remember we kind of did that really simple example last week? Well, let's try and do that in terms of a mapping kind of example, okay? So what we said last week was we said that 20 oranges is going to cost 100 cents or €1, okay? And then we're trying to find out how many, let's say 6 oranges cost, okay? 6 oranges cost what? So in that simple example there, 20 oranges cost €1, 6 oranges is going to cost 30 cents. How did we work it out? We took 100 divided by 20 and we got 5, and then we took 5 multiplied by 6. Everybody kind of follow that simple example? Alright, we'll try and write a method to do that, okay? If you think about what we're actually doing here, we're taking some number that maps from 1 to 20, and we're then mapping that same number onto the numbers, we're taking a number that maps from 0 to 20. In other words, the number of oranges. And we are mapping that onto the range 0 to 100. Does that make sense? So the number 0 maps onto 0, the number 20 maps onto 100, the number 6 is going to map onto 30. Does that make sense to everybody? That's the problem we were working on last week as well, where we had this range in a graph that was going from 0 to 150, and I wanted to map that onto a range of numbers on the screen, onto a pixel coordinates onto the screen. That's the same kind of idea, isn't it? Just maybe expressed in it as a different problem set, right? Could we write processing code to do this calculation? Yes, definitely we can. Okay, if you wouldn't know how to write a program to do this at this stage, you need to go back again and read the processing book, or maybe just have a think about coding or whatever, because definitely I think at this stage we should be able to write this in processing. Yeah? Does everybody agree? Yeah, we can write a couple of, like, multiply this, add this. Okay, it's very simple code, right? Let's try and write a method then, okay, to do this. And here's the method we want to write, okay? I'm going to write a method called mapRange. And this method, mapRange, is going to take 5 parameters. Okay, the first parameter is the number. So let's call this the value. Right, these are all going to be floats, by the way. Okay, so we've got a float value, and that's going to correspond to this number 6 coming in here. Okay, so we got this value. Then we have the range of that value. So we're going to say that map value's range is going to be onto. What should I call these? Let's call this lower range, upper range. And for lower range and upper range, we're going to pass in 0 for this, in this example, and we'll pass in 20 for the upper range there, okay? And then we're going to pass in 2 additional parameters. The first one is going to be, let's call this map to lower range. God, I should really think of better names for these variables. What does processing use for them?
How about inner lower range and outer lower range?
Yeah, that's a good idea. Let me see what processing calls them. Okay, calls it start 1, stop 1, start 2, stop 2, okay? Let's do that then. Comma start 2, comma stop 2. Okay, and start 2 and stop 2 are going to correspond to 0 and 100. So it's the range that you're mapping onto, or the second, or not the second 2, but the last 2 parameters in that method. Is that clear to everybody? So we take 5 parameters. First is the number that we're mapping from. The second 2 parameters then are the range of that number. And then the final 2 parameters are the values that you're mapping it onto. So to give you an example. Yeah, before we even code this, to make sure everybody understands, let's imagine we've written this method, map range. Let's see if we can figure out what would happen if we passed in some numbers to it, okay? So if I call in map range, and then I'm going to pass in 6 to 0, 20 to 0, 100, what will I get? You get 30. Okay, this is the problem we just solved, alright? So this is going to return, this method map range is not going to print anything, it's just going to return a value back. This will return 30. Okay, let's try another couple of values here. Let's try I passed in the value 10 and then I map that onto 10 and 20 and then I'm going to map this onto 50, 200. What would it return now? Look again. Oh yeah, sorry, it would return 50, correct. Sorry, my apologies. Does everybody see why this one returns 50? Okay, because 10 maps onto the range 10 to 20. So if 10 is the lower bound, it's the lowest of this value here. So that's why it maps onto the lowest bound here. 10 goes between 10 and 20 is what I'm saying. And it's going to map onto the values of 50 to 200. So if the value is 10, it will be 50. If the value is 20, it will be 200. Look at the previous one. Look at the previous one again. This is 6 mapping onto the range 0 to 20. And then that maps onto 0 to 100. So if the value is 0, it's going to be 0. If the value is 20, it will be 100. Does everybody see now why the value here is 50? 10 maps onto the range of 10 to 20. So that means that if it's 10, it will be 50. If it's 20, it will be 200. Everybody see now? Is that clear to everybody? Okay, let's do one more. Let's say I have the value 8. And let's say this maps onto the values of 0, 100. And let's say this is going to map onto 100 and 0. So what will be the value there?
Does 2 things in reverse for that?
You just work out the maths. It's the exact same maths.
92.
Of course, it will be 92. Yeah? So, do you think you could write this method? Okay, what I want you to do is write this method for this case and you'll find that it works for all cases. Alright, just take a minute to write that method, okay? It's called map range, takes 5 parameters. You can see what those 5 parameters are and hopefully you understand how map range needs to work. And that's the first learning outcome from today, okay?
Could you
Yeah.
just explain it again?
Sure.
The first part, I don't really understand.
Yeah, if you take the example of what we're doing there, I'll pause this for a second, right? Here, if you draw a picture. So let's draw a picture. Let's draw the first one, okay? Just tell me if there's a red light on that.
Yeah.
Yeah, cool, that means it's video. Alright, so the first problem. 6 onto the range of 0 to 20 and then 0 to 100, okay? Everybody, you understand the problem we're trying to solve here? Let's draw it out a little bit, right? So the first thing I have here is I have this input range, okay? This input range starts at 0 and goes up to 20. And then I have the number 6, which is about like this way along. It's about, there's 6 onto that, okay? Then I have my output range, which is 0 to 100. So there's 0 all the way up to 100, 0 to 100. And you can kind of see that you take the same percentage along from this line, and then you map it onto the same percentage of this line. So it's kind of a bit, under halfway. So you can see that this is like, that's 30 there. Can you see that that's the problem we're kind of doing? Does that diagram make sense to everybody? Have I explained it okay? So I've got 0 to 20 here, 6 is this way along, then we've got 0 to 100, and you can see that like, if this is, whatever percentage along this is going to be 6 over 20. You need to take 6/20ths of this one here. Isn't that what we're doing? Does everybody understand that? So you take 6/20ths of 100 and that gives you 30 there. Is that okay with everybody? Give me some feedback. Tell me if it's
Yeah.
okay or if there's a question, ask me. Okay? Okay. Everyone's really quiet today. Let's do the second problem using the same kind of approach. The second one is, I've got some number that's 10 up as far as 20. Now where's 10 on this line? 10 is here. It's right at the very start of it. And this is going to map onto the numbers 50 to 200. So I've got 50 over here and I've got 200. So you can see that 10 on this is corresponding to 50 here. This is the output value. Can you see that? When I draw these lines, does it make it clear the problem that we're trying to do? Maybe I should have done them as vertical lines and draw a line from one to the other. I think I'll do that next time. Okay, so in the second problem here, in the third one, we have the numbers 8. Sorry, we have the number 8. 8 starts at 0 and goes up to 100 here. And I have the number 8 here. And then over in this thing, I have the numbers from 100 to 0. And I need to go the same distance along, you know, so 8 is going to be there. So that's why I get 92 in this third example. Does everybody see that? Does everybody clear as to why it's 92 in the third example? Okay, can I just have a quick show of hands? Everybody happy? Nice. Okay, we'll move on then. All right, so we'll implement it. Now does everybody understand the problem we're solving? Good. Let's code it up in process engine, right? So what I would be thinking of here is the first thing I might want to do is I need to get the input range, okay? So let's call this. So my input range is equals to stop 1 minus start 1. Okay? That's the range of values I'm mapping from, and that's the range. Next of all, I need to find out how far along value is into the input range. So that's going to be, let me call this, how far along is going to be equals to what? It would be the value minus start 1. Okay, does that make sense to everybody? That's going to tell me how far along. You know, in this case, from 0 to 8, that's going to be value minus start 1. And then I need to find the percentage along. What should I call this? I'll just call it, what should I call it? Any suggestions? I want to find out what percentage how far is of the in range. Let's call it percentage in range. So that's going to be equals to how far over in range. That's going to tell me how far along percentage-wise, right? So again, thinking about the numbers that we pass in here, 6, 0, 20, you know, we're going to take 6 over 20 there to calculate percentage in range. And then we need to find out the same thing for the out range. So this is going to be equals to stop 2 minus start 2. And then it's just simply a matter of saying, see if we need to write this, we shall return percentage in range. Well, in fact, let's go start 2 plus percentage in range divided by out range. Now, is that right? No. Percentage in range multiplied by out range. Yeah, so it's a slightly, you know, we've separated it out into different variables here. But hopefully that makes sense for everybody when they take a look at the code. You know, if you just did it for the simple case up here, then it wouldn't work for values where our range doesn't always start at 0. But you can see now you can use this to solve any of these 3 problems. Is that okay with everybody? Does everybody understand that now? Okay, how many people got something close to it? Good stuff. Okay. Everybody understand now how this method works? The nice thing is, of course, we don't have to write this because it's built into processing, but I wanted to make sure you understood what it did. You can just call the method map. Okay, the method map is built into processing, and it does exactly that for us. It allows us to take one number in a range and map it onto another number in a range, and that's how it works. And that's why we spend some time to write it ourselves so that we understand how to use it. So next time when we're writing some graphing code and we need to map from some range of numbers onto some range on the screen, we can use this map method. And you just pass in the parameters, and then it will allow you to map things onto a range. Okay, that's learning outcome number 1 for today. Is everybody happy? We've all learned something. It's good, isn't it? Brains in gear? Let's get ready for the next thing then, okay? The next thing is, sometimes when we write computer programs, we don't know in advance how many elements we need to put into an array. So wouldn't it be really cool if there was a special type of an array that could grow and shrink, and then you could insert values into the middle of it, and it would move things around appropriately? Wouldn't that be really cool? If only there was something that could do that for us. Well, I'm happy to report there is something that can do that for us in processing. And it's called an array list. Alright? So here's how an array list works. In fact, you know what, I'll code this one up, right? So, although an array list is very similar in usage to an array, the syntax for an array list is really different. Okay, so I'm gonna show you the equivalent array list and an array code. We make an array and we make an array list, right? Let's make an array and an array list that kind of do the same thing. Let's make an array of floats first of all, right? So if we were to make an array of floats, you go float ARR equals new float, and we'll say we put 5 elements in there, okay? And then to put something in, you go ARR at position 0 is equals to the value 99, and so on for all the, we'll just do 3, for all the elements in an array. So say we put 3 in there. Okay, so that's how we would add things into an array and allocate an array capable of storing 3 elements, right? We'll do the same thing with an array list, okay? An array list looks like this. First of all, an array list is another example of a class in Java. It's an object. So we access it via methods and stuff, right? But the syntax for an array list looks like this. First of all, we have these new symbols here. These are normally used for greater than or less than. But in this context here, this is an example of something that we'll do a bit more on the second semester. It's an example of passing a type as a parameter. Okay, and what we're passing here is the float type. Now, another interesting thing that you need to learn when you're using things like these angle bracket stuff, right? The angle brackety things in Java can only be used with what are called can only be used with objects, right? So you wonder, why can't I just put the word float in here? If you just put the word float in there with a lowercase f, your program won't compile. And the reason why is because float is what's called primitive type in Java. And you need to use what's called a primitive type wrapper. So pretty much there are primitive type wrappers for integers, floats, booleans, etc. Strings are okay. You can make them from strings because strings are already objects. But when you want to put integers and floats into an array list, you have to use float with an uppercase F. So we need to get into the habit of doing that when we're doing array lists, okay? And this is a primitive type wrapper for the float. That's what it's called. So we've got array list float. Let's call this ARR list equals new array list. Float with an uppercase F, and then open and close brackets like that. So the syntax, as you can see, is completely different. It doesn't look at all like an array, but it is in fact something that we can use in a similar way to an array. We can just allocate it in a completely different way. That's what an array list looks like. So now we have an array list. This array list initially has 0 elements in it. So we can add things to the array list by calling a method on the array list. So you call ARR list dot add with a lowercase a. The dot there means what we're doing is we're calling a method on this object. Same as we did stuff like, what did we do? Substring. String.substring. And then let's add the same three elements. 99, 10, and 10. So the array list starts out with a size of 0, and then every time I call add on it, it will add an element to the array list, and the size of the array list grows by 1. In the background, what's happening here is Java has actually allocated a big array for us. It's keeping track of what's the last element in the array, and if I add more elements than there is space to size to hold the array, what it will do is it will go and allocate some more memory for me and resize the array. You can also call, I think it's .insert and .remove. So you can insert things in the middle, and you can call remove to remove elements as well. So it's quite handy. You know, if you're to try and do this yourself with an array, say you want to delete something from the middle of an array, how would you have done that, or how would you do that? What's the only way to do that in C, or just using an array?
Moving everything. So
Yeah, you got to move everything back 1. If you want to delete something from the middle, you got to move everything that's subsequent back 1. In actual fact, that's what's happening here as well, but it's hidden from you by this method, and it just makes it much easier to deal with data that's going to grow and shrink, right? If I want to iterate this array list, you go for int I equal, in fact there's two ways to do it. I'll do the long-winded way, and then I'll show you the for each way as well. For int I equals 0, semicolon I is less than. Now, if I was to do array, how would I calculate the number of elements in R, A-R-R? I use dot length. Okay, for an array list, you use A-R-R list dot size. Don't ask me why. I don't know why. Two different people probably wrote this code, and one person put dot size, another person put dot length. I don't know why they don't use the same ones. But it's just, that's Java. I didn't make it up. So let's print ln ARR list. Oh yeah, to get an element out on a particular position, you call it .get. So that will go through the array, and it will retrieve element number 0, then it will retrieve element number 1, then retrieve element number 2. Yeah, is that okay?
Doesn't the add 99 need to be a float?
It should be, yeah, but what will happen is it'll use an integer and then change it to a float. But you're right, we should really do this. Yeah, that's much better, okay? I don't, it's much better to explicitly say it's a floating point number that we're adding. Okay, so there we go. We're printing the elements. And then the other way to do it is to use the for each loop. So you can go for float f colon ARR list. And remember we talked about for each loops? This is the for each loop for an array list. So both of those do the same thing. They both go through each element in the array list and print it out. In the second example there, what happens here is that element number 0 gets copied into F. This code gets executed and we print the value. Then element number 1 gets copied in for F, and then this code gets executed and we print the value. And then element number 2. How's that? Everybody happy with array lists? There's not really much to them. It's just the syntax is different, and you just have to get used to typing different code when you want. In general, array lists are kind of more useful because of the fact that you don't have to specify, make me an array list of 5 elements. You can just add elements on as you choose, and then you can delete them as you choose, and so on. Is that okay with everybody? There's not really a lot more to array lists than that. I'm pretty sure it's .remove and .add to add and remove things to the array list. How's that with everybody? Okay? Alright with everybody? Okay, the last thing then, and then maybe it's time for you guys to write a program as well. There's another thing, a really cool thing in processing called load strings. This isn't part of the Java language as such. This is something that processing provides us with. Array lists are in Java. Everything we've done, in terms of variables and all that kind of stuff, of course this is just Java, but this is a cool processing thing. in most programming language, you guys did a subject called programming persistent data last year, did you?
Not all of us.
Yeah, we did.
Okay, did you load files? Cool. How many lines does it take to load a file in C? Did you do file pointers and read and write and print ln or fprintf and all that kind of stuff? Did you do all of those last year?
Yeah.
Okay, well I'm pleased to tell you that all of that is replaced with one line of code in processing. Is everybody ready?
No.
Is this really good? Okay, it just returns you a string array, string, like this. Sorry. Load strings. And that will load the entire file up into an array of strings, where every line from the file becomes a string in that string array. So, let's try doing something really simple here. So the first thing that you pass it, this only takes one parameter, and that's the name of the file you want to load. So I'm going to just make a note on this because it's really important. The files that you load from processing have to be in a folder called data inside your sketch. Right, so files must be, and you can put a note in your sketch and everything, must be in the data folder. Right, so if you have, let's just load up a simple file and make the file and everything. Let's call this hello files. Okay, so we're going to load this string called hello files.txt, and let's just print them all out. So we'll do a for each loop, why not? For string s colon lines. lns. Now look very carefully at this for each loop, right? What's going to happen here is lines is a string array, so this is going to have like, I don't know how many lines are in that file. If there's 100 lines, there would be 100 elements in that string array. And then for string s colon lines, every line, every string that's in this string array, each one gets copied into the string s, then this code gets executed for every value. So this is the same as writing for I equals 0, I is less than lines.length, I plus plus, and then print ln lines at position I. Is that okay with everybody? So we'll make this file, we'll put it into this location, and we'll test to make sure it works, and then we want to take a short break. Alright, so there's everything all set up on my sketch. I'm going to save my sketch, because we need to save the sketch somewhere first of all. Let's go into Documents, Projects, sorry, Documents in my situation here. It's Courses, this one here, Processing. I'm going to make a folder. Oh yeah, if I just give the sketch a name here. Let's call this Files 1. So there's my sketch, Files 1. If I just go and run the sketch now, of course that file won't exist, so my program will probably throw a null pointer exception, okay? Because it's, and you see this printed out on the console here. The file hello files.txt is missing or inaccessible. Make sure the URL is valid, blah blah blah, because the file doesn't exist, right? So let's go and make the file. So if I jump back into the folder where I've saved that sketch, Processing, Files 1. In this folder, I am going to make another folder called Data. So new folder, Data. And in here, I'm going to create a new text document. So new text document, and we call this file hello, what do we call it? Hello files? Hello files.txt. I'm going to right click on this and I'm going to choose edit with Notepad++, and let's put some lines in this file. Put whatever you like in there. don't have to take the tone down. If you want, you can. Now when I run my process in Sketch, oh my God, look at that amazing, amazing look. Everybody, it's just the best thing. It has printed out the lines of the poem processing, because it's read it into that string array, and then we printed out each line from the string array. So I'll put the code up again if anyone wants to see it. There's the code there. So once you get your file to load and print out, we'll take maybe a 5-minute break, okay? And then what we'll do is, now that we know how to use map, now that we know how to use an array list, what we'll do is we'll load a data set into an array list. And we'll do some things with it in the second half of today's class. Okay, everybody? So just make sure you got the files thing working, and then we'll take a short break, okay? Okay, first of all, there was like 2 other things I just realized that I could have probably explained to you earlier on that we need in order to do this week's kind of problem. Okay, first of all, we can now load a file. We can get each line of the file into a string. A comma-separated value file looks like this, however. Documents. By the way, go ahead and open up one of those CSV files that you downloaded. If you jump into the folder that you have your stuff in. You don't open it in Excel, just open it as a text file, right? So, let me get the 2 files that we downloaded. You can drop them into that folder as well. See the Dublin Airport and sum.csv. If you want to take those files and drop them into the files folder in the project that you've made, the data folder I should say, so that they're there beside hello files.txt. We can use those in our program. Let's open them up and have a look. Let's have a look at sum.csv, because this is a simple file. This is the first one that we'll do, because it's really simple. All this is a list of numbers in this file, okay? This list of numbers, the weather data sort of data set that we're working on, what I've done is I've loaded that up into Excel, I've done some calculations, and this is the output. But this is basically the sum of all of the rainfall recorded at the weather station in Dublin Airport from 1850 up until 2010. Alright, so this is the sum of all the weather data recorded there. Apparently there was a weather station there even before the airport, so that's why they still listed as Dublin Airport. But the first number there is for 1850, and it goes on up until 2010, okay? So, yeah, that's the sum data. If we want to look at what an actual CSV file looks like, it's a little bit more like this. Dublin Airport, this is the actual data. So, this is the actual data, and I've kind of cleaned this very slightly because it had some rubbish at the start here, but the first element in this file is the year, and then we have all of the rainfall data. So there's 12 data points, you know, going across after the year, one for every month. Does everybody see how the file is structured? And each element in the file is separated with a comma. Can you see that, everybody? Alright, so it'd be kind of nice to be able to read each of these lines as a full line and then separate it into separate bits separated by the comma. You know, how would we do this in C? If you were to do this program in C, if you had one big string and it was delimited with commas, how would you figure out which bits are the data and separate out that into different bits so that you can get the bits without the commas? How would you do it in C?
Individual characters and then check if they're commas.
Yeah, you would have went like for I equals 0, I is less than the length, or you know, for I equals 0, no, you would have written a while loop. You would have while the character is not equals to the end of string character, and then check to see if the character is equals to the comma character, then you store off the last bit of the string and then do all kinds of weird string parsing. In Java as well, there's a really cool way to separate a big long string out based on what are these things here. These are, by the way, in programming, these are called, does anybody know? These commas in this file here, they're known as what? Anyone? Delimiters. They're known as delimiters. Okay, let's write that word up so you have it. D-E-L-I-M-I-T-E-R-S. Delim, T-E-R-S. They're delimiters, because they delimit the data, okay? That's what they're called, delimiters. Okay. We'll pick our little file that we've looked at already. Just to show you how you use delimiters and how you can separate things out. Okay, so here we are in our little program loading up the poem. Say I want to separate out all of the words in each sentence. This is how you would do that, right? You would make another string array. S dot, oh, it's so simple. S-L-I-T. Like that. Words equals S dot split. But what this will do is it takes the line, each individual line, and it will split it based on the space rather than a comma. So every time it comes across the space, it will create a new element into the array words. And the array words that comes back is going to be each of the words that it found, and it will separate it out based on the space. So then you can go for string W colon words. Print W. So, you know, this is just a toy program here, but nevertheless we can get the gist of what's going on. Just so you understand what's going on, what's happening here is each line is going to get read into the string array lines. So that's an array. If there's 10 lines in the file, that array will have 10 elements in it. Each word then, each line then gets split based on the space. So all of the words that's in each of the lines then get split into another string array called words. And then words is going to have each of the words. So if I print this out now, what's going to happen is if I run the sketch, I'll get the entire line getting printed out, and then I'll get each of the words printed out in a separate line. So try that sketch and see does it work. Hopefully this will work. Now, if you look at what the output is, the first line is I wandered lonely as a cloud, and then it split that out into I wandered lonely as a cloud. You see, so it's split it into the second string array, word by word. So that's how we take some long string and we separate it based on a delimiter. This is a space, you know, in your lab tomorrow you can do it based on the comma. Is that okay with everybody? Everybody understands split? Okay, one final thing then, okay? And then we're ready to do some coding with that data set. Occasionally, things that I read from the file, and in fact mostly, all the time I should say, when we read stuff from a file, it comes to us as a string. If I want to do something with that data, I need to probably convert it to a float. Alright, how would you convert from a string to a float in C? Anybody know how to convert from a string to a float in C? There's at least two ways in C. Does anybody know how? So you could have used a method called scanf. Alright, you could use that method, or you could use, I think there's ATOI, which is ASCII to integer, and I think there's ATOF, ASCII to float. So that's how you do it in C. In Java, it's kind of different. Let's say I make a string. Let's call this string fval. And I say it's equals to the string 100.99. Alright, that's the string value. If I want to convert that to a float, you go float fval is equals to float uppercase dot parse float fval. There might be a nicer way to do it in processing, but this is the Java way to do it, okay? Processing sometimes has got kind of wrappers for doing some of this stuff, but it's good to get into the habit of doing it kind of long, even though the Java way is slightly more long-winded. This is the Java way, okay? I think you can just do, yeah. Oh, let's call this fsval, or string version. Okay, either of those approaches will work. Okay, parse float is something that's built into processing, If you tried to do that from a standard Java program, it wouldn't work. So that's why I think it's better to learn how to do it the Java way, which is to go float with an uppercase .parse float. There's a fair bit of stuff that's happening here, you know, that's what's called a static method on the float class, and it can potentially throw an exception, but we don't need to worry about any of that stuff for now. This is how you convert from a string value to a float value. This then is how we split a string, this is how we load a string. We know how to use an array list as well. So, I think it's time for us to try and bring all of this stuff together by writing a small program. What do you think, everybody? Everybody excited? We should answer a question from this data. Okay? Here's the data set, the first data set. We look at the simple data set first of all. The simple data set is sum.csv. And sum.csv just has the total rainfall recorded starting at the year 1850 and going up as far as the year 2010. Alright, so this is the total rainfall. Could we now write a program to tell us what was the wettest year since 1850? And while we're at it, what was the driest year? What do you think? Could we do it? Have we got the tools? Do we know what we need to do this? We have the array list. We have the loading strings thing. We have converting from strings to integers. Or strings to floats. Why don't we take maybe 15 minutes to see if we can answer that question, okay? Let's have a crack at that. You guys have a go first, and then we'll come together as a class, okay? And we'll write the code together. Yeah. Sure. The first one starts at 1850. Okay. Remembering all the tools that we have, right? And it's a matter of then knowing, you know, what bit of code to put where and what syntax to use for what. Let's go and find the program we're working on. Here's the files program. So if you look at this, pretty much everything we need to do is in here. But let's do this really quickly. Let me comment out this line of code here, and then we'll write all of this stuff again. Okay, so what I want to do here is I want to go and load every string from that file into my string array. So the file is this time is called sum.csv. Okay? So now, this array lines is now filled with every line from the file. Okay? And it's in a separate element in the array lines. So then I can go for string s colon lines. So this is going to iterate through that array of strings, and for every element in that array of strings, it's get copied into S, and this code gets executed. This is the same way as going for I equals 0, I is less than the number of lines.txt, number of lines dot length. Okay, next thing we want to do is convert each line to a float. So I can go float f is going to be equals to float dot parse float s. Alright, so what's happening here is I've now taken the line of from the file, and I've now converted it into a float. And let's make it array list. Array list, let's call this sum data equals new array list float close bracket. That's the syntax there. So then you go f equals parse float. To add it, you go sum data dot add f. So now I've taken each line, converted each line one by one into a float, and then added it to the end of the float array. So at the end of this code, the size of the float array will be the same size as there are numbers of lines in the file. Does everybody understand what I've done there? I haven't done any summing or anything yet. Let's write the next thing. Then I want to find out where was the lowest. Okay, so we can do this Same way that we did the lowest kind of, minimum, maximum last week. Let's go float M for minimum. Let's call this, okay, let's call it lowest. And let's set that equals to some data dot get, which is how you get something out. In the same way we do square brackets for an array, you use dot get for an array list at position 0. And let's make this next one float int lowest index is going to be equals to 0. Alright, so this is basically saying the lowest one is the 0th element initially. And then we go for int I equals 0. I'm going to use it indexing rather than using for each loop here because I need to remember the location. Equals 0, semicolon I is less than some data dot size, semicolon I plus plus. Alrighty, and then we can check to see if, in fact, probably should start this at 1 because we've already checked element number 0, same as we did for minimum last time. If some data dot get at position I is less than the lowest, lowest is equals to some data dot get position I, and then lowest index is equals to I. Now if you remember last week, this is exactly the same code that we used last week to calculate the minimum index in an array. We did this code last week if you recall. The only thing that has changed from this week to last week is I've changed it from an array to an array list. So I'm using .get instead of square bracket notation. So that's going to tell me which is the lowest index. And then we can go print ln. What did we want to figure? Oh, hang on, it's the lowest, not it's the highest we want to figure out. Okay, we'll have to do the lowest because I've written the lowest and we've no time left. We'll find out which was the driest year then instead of the wettest year, okay? Now, we know that the years start from 1850. So if I get index number 0, I'm talking about year 1850. If I really wanted to, I could use the map method for this. Maybe we should use the map method for this.
Oh, that's fine.
It's easy. It's even easier if you just take it's equals to 1850 plus I. Plus the lowest index. With a rainfall of some data dot get. You have to use this long-winded way of getting things out of an array list. At position lowest index. There we go. That's going to give me the driest year. So all I've done here is taken my array of strings, converted it to an array list of floats by going through each element of the array of strings, converting each array element into a float, and then adding it to the array list of floats. And then this other code here is the same code that we wrote last week to calculate the minimum of an array. And you're just using .get at position I instead of using square brackets. And yeah, because we know it starts at 1850, take 1850 plus the lowest index with rainfall off, and so on. Anyone have any intuition as to what the lowest or the driest year in the last 150 years was? I wonder, was there any particularly dry years that we can recall?
1942, I believe, is right.
I think it was about 472 millimeters rain.
Very good, very good. You obviously are studying this daily and memorizing.
I always watch the webcam.
You remember 1942. Okay. Wow, look at that. It was actually 1887, so you were wrong. It was 1887 with rainfall of 402 centimeters that year. We must look that up and see what was the wettest year. I'm just curious as to see what was the wettest year.
2002.
What was it?
2002.
2002. Was it a particularly wet year in 2002?
Oh yeah.
Somebody Google it. Okay, we'll leave it at that for have a great weekend. See you in the lab tomorrow.